Want to thank everybody for joining. My name is Rocky from the Avalanche Labs team. Really excited to host this workshop. We're going to be jumping into basically a developer workshop with Patrick Collins from the Chainlink Labs team. He's going to be showing us how to implement price feeds on Avalanche. So without further ado, Patrick, why don't you do a little intro and then we'll get right into the demo. And if anyone has any questions throughout the tutorial or workshop, please feel free to use the Q&A box at the bottom of your screen. But Patrick, take it away.
Yeah, awesome. Yeah, thanks so much. Really excited to be here. Really excited to be chatting. This has been, I know a lot of work from a lot of teams, and this is just, it's great to be here and be talking about Chainlink and Avalanche. So I do have a number of things I want to talk about, and let me go ahead and share screen to get it kicked off. So first, if people here haven't seen Avalanche, Chainlink has this wonderful combination right here. This is the Avalanche, or excuse me, this is the Aave application. And being working on the Chainlink protocol, I absolutely love seeing Aave do things, right? Because they kind of are the Chainlink price feeds, the Chainlink data feeds really power kind of their whole pricing of the collateral. And then just seeing, Avalanche kind of connect with Aave is just absolutely monumental, and seeing them almost hit the $2 billion mark in total locked value is just amazing. So this is the type of stuff we could build, right? A $2 billion protocol. I think this has been up for like less than a week. Well, I think Rocky was telling me it was like a few days. I forget when the application launched here, but these are the type of applications we could build using Chainlink and an Avalanche here. So with that being said, though, let me go ahead and jump in here. We're going to be talking about a number of things today, and there are 14 people here in the that yield though 14, 15, 16 people here in the Zoom. Sorry, YouTubers, I won't be able to chat with you, but since we have a small group in the Zoom, definitely feel free to jump in, ask questions. We can make this nice and collaborative. I'm going to try to save some time at the end so we can chat about, whatever we want to chat about, really. So let's jump in. Again, for those of you who don't know, my name is Patrick Collins. I'm a developer advocate on the Chainlink protocol. My Twitter avatar is there at PatrickAlphaC. LinkedIn contact information is there. So in order for us to really understand the purpose of Chainlink and what Chainlink even does, we first need to kind of get a quick refresher on what smart contracts are, right? What are they doing? Why are they so important? Why do we care? Why do we care about this whole thing? And the reason we care is because smart contracts solve this issue with traditional agreements and traditional contracts, right? In your traditional contracts, there is some entity or some individual that owns the execution and operation of the contract terms, right? They write the terms and they say, hey, here's what we promised to do. Here's what we're going to do. And they make all these promises, right? They make all these agreements. Now, oftentimes, the people who are making these agreements have this conflict of interest, right? For example, if they say, hey, on Tuesday, I'm going to pay you $200 or something like that. Tuesday comes around, they have to pay you $200. The onus is on them to execute their end of the bargain. And you, on the other side of the agreement, have to trust that they are going to be the ones to do the right thing. So we enter this world of counterparty risk where those who need to execute their contracts, they're kind of disincentivized to do so, because I don't know if you know this, but I'm not in the habit of just wanting to give people $200 or wanting to give people money. Now, obviously, that's kind of a silly example, but you can imagine larger examples, like an insurance contract, right? Or an insurance agreement. The insurance company doesn't really want to pay out, right? Because they're not in the business of giving money away. And that's kind of the issue that these smart contracts solve. Instead of trusting in the brand of these applications, we trust in the math or the code. So instead of somebody saying, hey, I promise I'm going to do this, the code says, I am a math-based agreement. 1 + 1 = 2, therefore this is going to happen. So we can move away from this brand-based trust to cryptographic and math-based trust, right? We don't have to say, okay, I'm going to trust your logo, I'm going to trust whatever. We just know that, okay, the code works. Right? I can read the code. I know that if this, do that, boom, the cryptographic guarantee is much stronger than a brand-based guarantee, right? With these brand-based, these paper guarantees, if we don't like a service or somebody breaks a promise, all we can do, our only option, is to walk down the street to the next group or the next entity who ultimately can only make the same set of promises ultimately to potentially break those promises as well. So we remove this trust issue, along with a few other issues, which I'll go into in just a second. Another fantastic example of this that happened recently was with Robinhood. Robinhood made all these promises of, hey, we are democratizing finance. We are your gate into the financial realm. And when push came to shove, this picture that they painted and all these promises that they made eventually fell apart, and they were not actually able to enact and do what they were promised to do. Right, you were not able to buy certain stocks because they didn't want to. They had a centralized key to the markets and they turned it off. They said, okay, never mind. You're not allowed to engage in, and do this, these financial transactions that we promised that you could. And whether or not it was right of them to do that, it doesn't even matter. All that matters is they had the power to remove your ability and go back on their promise. And that's the main issue there. So smart contracts, they're these superior digital agreements. This trust issue is kind of, in my mind, one of the biggest benefits here, but they also have more security, there's guaranteed execution, there's more transparency, which is actually massive, and they're also incredibly efficient as well. So these smart contracts are amazing. Now, cool, we have these smart contracts. Awesome, the world is a better place. They can do everything, they can solve everything, right? Well, not quite. These smart contracts still have something called the Oracle problem. And these blockchains have something called the Oracle problem, where they're unable to connect with external systems, data feeds, APIs, and existing payment structures. Now, this is actually intentional. This is done by convention, right? There's a reason for this. And it's because these blockchains are deterministic by nature. If you try to introduce variable data or non-deterministic data into these blockchains, into these smart contract platforms, all the nodes would get confused and they wouldn't be able to reach consensus, right? Because if you told one node, hey, can you get me a random number? Another node, hey, can you give me a random number? They're all going to have different random numbers and not going to be able to reach consensus. Or if you asked different nodes to make API calls, maybe the time that one node makes the API call, the values changed, or another one, and they're never going to reach a true consensus on what the state of the blockchain is, which is obviously a massive issue. So they can't do that. And this is an issue, right? Because as we just said, these smart contracts are these superior digital agreements. Well, guess what? In agreements, I probably want to interact with the real world in some way. If I have an agreement in the real world, I probably want it to be in regard to the real world. So smart contracts alone, they can't access retail payments, market data, events data, bank payments, really anything outside of tokenizing, smart contracts and tokenizing applications. So this is where blockchain oracles come into play. So a blockchain oracle is going to be any device that interacts with the off-chain world to provide external data or computation to smart contracts. And you might be thinking, oh, okay, cool. We'll just use an oracle. We're good to go. Oracle problem solved. We can go home now. Not quite, right? So centralized oracles are still a point of failure. If you have done all this work to make your decentralized computation layer on chain, your decentralized logic layer on chain, decentralized, and you have a centralized node or a centralized data point, you've reintroduced this centralized key for someone to shut off your dApp or your application. So delivering your data or delivering your execution through a centralized point essentially removes all the benefit of doing all the work to become a blockchain engineer, right? So we need to have both our on-chain layer, our decentralized computation, our decentralized logic layer, decentralized, and our off-chain data and our off-chain computation also decentralized to have a truly decentralized application. And this is where Chainlink comes into play. So Chainlink is a decentralized Oracle network that connects these blockchains to the real world in a decentralized context. So it's bringing data on, doing external computation, maybe getting a random number, event-driven execution, whatever you want, flowing through a Chainlink network to really just empower these blockchains to do even more, right? So for Avalanche is a fantastic blockchain, and Chainlink is here really just a buddy and give it even more power and let it be even more customizable to do more things. It's like the superpower for especially a chain like Avalanche, which has so much throughput and such fantastic consensus mechanisms and everything. This gives rise to something known as hybrid smart contracts, right? And hybrid smart contracts have both an on-chain and an off-chain component, where the off-chain is going to be external data, enterprise system, traditional payments, etc. And then your on-chain is going to be your smart contract code, it's going to be your Solidity, it's going to be your Viper, or whatever you want to do on-chain. So that's the high level of Chainlink. Again, since we have kind of a smaller group here, I'm happy to pause real quick, excuse me, with any questions on any of that. So I'm looking at the chat here. I'm looking at the Q&A. No questions from Jason. Okay, great. Do we get a POAP NFT for attendance? Not from me. Sorry. No questions. Okay, all right. We're up to speed. Great. So Chainlink features. Let's talk about some of these out-of-the-box features you can work with for Chainlink. And the main one, and the one that we're going to be talking about today, and the one especially, that that was just used in integration with Aave and Avalanche here, is going to be these Chainlink data feeds. And right now, they're powering over $50 billion in the DeFi ecosystem in the DeFi world. What are these data feeds? What are they doing? Well, they enable DeFi to really just superpower and go 10x, right? So most financial instruments and financial applications, they need a way to price some type of asset, right? Whether it's a stock or a cryptocurrency, they need a way to price it to do whatever financial instrument they're going to make. So Chainlink data feeds take data from the real world, from the exchanges, from different financial APIs. They route it through a network of decentralized Chainlink nodes and deliver it into a price reference contract on chain for different applications to then use and build these massive financial projects with. Here's kind of a quick example of what these look like over at data.chain.link. And we can even move over to Avalanche, and we can see some of these feeds here. For example, AvaX USD, we can see this is a decentralized answer to the price of Avalanche in terms of USD, right? And we can see here kind of the different decentralized oracles that are responding with this information. We can see kind of the price volatility in the past history, and these update actually pretty regularly, so we can see more updates here, which is really cool. We can see all the different nodes who are responding, and we can see that some of the different users at the bottom who are sponsoring these data feeds. Obviously, Aave being one of them. So this is a contract on chain that is having this data stored into this contracts for other contracts to read from, right? And if we even go to read contract here, we can see latest answer. This is going to be your latest answer for the price of AvaX in USD. Now it's really big, right? Because it has an additional 8 decimal places, because Solidity doesn't work with decimals. So we know price of, this many decimal places. So we know the price of AvaX is going to be around $60 USD. But it's this tool that empowers these applications to go the extra mile. And here's kind of a visualization of what the architecture of this looks like, where we have this network of nodes off-chain. This is called the OCR, or off-chain reporting model. All these nodes off-chain, they're all talking to each other, they're all making API calls, they're all getting data. And then in a single transaction, they send that data to these smart contracts. They all sign all their data so anybody can use it for your applications. Here are some of the protocols that use these price feeds and are being secured by Chainlink. You have Synthetics, which has around $3 billion. SushiSwap, another $3 billion. Compound, something like $10 billion. Aave, something like $15 billion. And it's probably even more with Avalanche and whatnot on it. And it's these applications that are proving kind of the battle-testedness and quality of these Chainlink price feeds, how decentralized they are, how powerful they are to build, these several billion-dollar protocols with Chainlink price feeds. So this is easily one of the most powerful tools in the space, enabling you to make even more insane smart contract applications. And at the end of this, we're going to do a demo through the documentation. The documentation has what we call one-click documentation, where you can click a button, get into an example here, and we'll show you that at the end of this demonstration. And one other quick thing, DeFi is still only like 4% of all value in cryptocurrency. So if you're racking your brain for things to do, DeFi is a great place to be. There are insane DeFi applications being built, and there are insane DeFi applications still yet to have been built. So With that being said, I am going to briefly touch on a couple of other applications. They're not on Avalanche yet, but I'm sure they're being worked on right now. So just really briefly, Chainlink VRF or Chainlink Verifiable Randomness Function. Blockchains themselves, again, because they're deterministic, they can't get true random numbers, right? By definition, a random number can't be deterministic. So we need to look outside the blockchain. Chainlink VRF gives us a way to get a verifiably random number into our smart contracts, and it uses some crazy cryptography to actually prove that the number is truly random. We've seen protocols like Pool Together, Axie Infinity, Ether Cards, Avagoches, Pokemon, all using Chainlink VRF to get these random numbers. It's absolutely massive in the gaming space. Another really powerful protocol, not on Avalanche yet, but I'm sure it's being worked on. It's going to be Chainlink Keepers. Oh, whoops, sorry, it's cut off a little bit. But one issue a lot of these smart contracts have is that somebody needs to make a transaction to update some type of state, right? Their smart contracts can't trigger themselves. You need some transaction. Someone needs to spend some gas to do something. Now, you could absolutely have some like off-chain server, calling functions or doing things, but then again, you've reintroduced this centralization point, right? So in order to have our applications decentralized and do event-driven computation, we need a decentralized way to do that. And that's exactly what these keepers do. So quick visualization, different smart contracts will register a certain function with a Chainlink on-chain contract called the registry. The Chainlink nodes will be reading off this registry contract, reading for these events to have fired, whatever these events are. Once an event has fired, it'll say, hey, an event has fired, and the Chainlink nodes will go, okay, cool. We're going to do whatever you have defined in your smart contract, right? We're going to do whatever you've told us to do. And that's pretty much it. And Chainlink really enables developers to do whatever they want to do. So another feature that we actually didn't go over here is going to be making an API call. You can make any API call you want with the Chainlink node. So for example, like if you wanted to make this API call and get something from this massive piece of data into your blockchain, into your smart contract, you absolutely can. And Chainlink is the tool to use this. Now, keep in mind, obviously, if we're going to pull from one single API, that is, again, reintroducing this centralization vector. So this one does take a little bit of extra legwork to get going in a truly decentralized context. But again, if you're looking for unlimited customization of flexibility, it's this tool right here. You can combine this with a group of other nodes, a group of other pieces of data to make your applications do anything that you want to do. With that being said, let's talk about some places where we can learn and grow and learn about all this stuff and build these insane smart contracts. So the docs.chain.link, I kind of like live in here. Docs.chain.link pretty much has everything that you need. If it doesn't, you can always make an issue. Or actually, we just released this getting help section, which kind of talks about making Stack Overflow issues, Stack Exchange Ethereum, opening an issue on GitHub, etc. Definitely check that out if you're looking for some help. Oh, and then join the Discord, of course. If you're looking for ideas, there's a fantastic article called 77 Smart Contract Use Cases Enabled by Chainlink. Definitely check it out if you're looking for some ideas. Again, where can we learn? Documentation, blog.chain.link. Tons and tons of blogs here for doing pretty much anything. NFTs, DeFi, DAOs, you name it, it's there. Chainlink YouTube has a ton of developing tutorials. The engineering tutorials and developer workshops playlists in particular have all of our engineering-y workshops we've done. There are the Solidity and Smart Contract Starter Kits with Brownie, Truffle, and Hardhat for anybody who's looking to just kind of get some boilerplate that already has tests, that already has contracts in it, so they can just drag and drop and start going right away. And then there's a ton of places to interact with the community, like in the Discord, like on Stack Overflow, on GitHub, all over the place. There's tons of people to connect with and community members to work with. So these are some of the main places you can go. Highly recommend joining, the Discord, saying hello, joining Stacking Overflow and saying hello as well. So with that being said, we'll take a minute to do some questions. Then we'll jump into some examples, and then we'll do like kind of a Q&A about whatever we want to do here. So can you get data from a resume and add it to the blockchain? You absolutely can. Any API call you can make. right? So all you have to do is put your resume into an API and boom, you can get into a blockchain. Good question. Any other questions?
There's a couple in the Q&A box.
Oh, yep. Do you know of any NFT rental contracts? Yeah, I do actually. Is it Ren NFT? Re-NFT? I think that's what these guys are doing. Peer-to-peer non-fungible NFT rentals. Yep. So they're one that does this. Curious why you're asking. Are you asking like, oh man, did somebody already take that idea? Because if that's what you're asking, you should still 100,000,000% do it. Right. There's always room for collaboration and growth and everything like that. Good question. Type answer. Answered. Send. Why are there so few tokens available for Avalanche, and how do we get more set up? Good question. It's probably still a work in progress. I mean, if you're comparing to Ethereum, it's probably just because Ethereum has been around longer, right? That's really it. Good question. And how do we get more set up? Do you need to get more set up? I mean, yeah, if you want to get more set up, absolutely. Oh, it doesn't let me answer it live. Okay, type answer. Answered. Oh, it says Rocky's going to answer this question. Oh, okay. Yeah, well, all right, we answered. So cool. Any other questions? Okay. We have a question here. I'm looking for a form that I'm going to send you all. Actually, hold on. Before I answer that last question, I do want to drop this in chat. And then Rocky, if you're in the YouTube, that would be great to drop to them too. So I should have mentioned this before. Anybody who's looking to do something insane should absolutely come to the Chainlink Hackathon. So chain.link/hackathon, excuse me, or hack.chain.link. It's going to be absolutely wild. If we scroll down, we have Gabriel, who's going to be part. Eamon. I'm sorry, I always screw up pronouncing.
You can just call him Goon.
Goon. Everyone calls him Goon. So should I not even bother with the first name? Should I just call him Goon?
Yep, Goon is good.
Okay, cool. So Goon's going to be there, obviously, and it's going to be absolutely insane. We have a ton of workshops for literally anything you want to do with smart contracts. There are prizes for just learning about smart. Like you can win a boot camp seat. Like if you're not going for like the money prizes, right? You can just win learning more about Solidity. So if you're brand new, it's the place to go. If you are looking to go mainnet and do crazy stuff, we have a VC pitch day, which is going to be insane. Hold on, let me scroll down to the VC pitch day. Judges and speed. VC. We have a VC pitch day where you'll able to pitch your project to VCs to get sponsorship in addition to winning prizes. Absolutely wild. So both if you're brand new and if you're an expert, or if you're in the middle, you're just looking to network and grow with people. Like this hackathon is going to be absolutely wild. We have a ton of events. We have a bunch of fun events too. Definitely sign up if you haven't already. And again, doesn't matter where you are experience-wise. Totally noob to this stuff, great, join. If you're experienced veteran, great, join. Okay, now I'll answer the last couple of questions. What is the gas fees to keep stuff in the blockchain? Good question. So that's a long answer. Well, the short answer is it's, once you've deployed it, it doesn't cost anything, right? So whenever you deploy something to a blockchain, and there are a couple blockchains that do it a little bit differently, but let's just focus on Avalanche. Hey, look, 2 Billy. Hey, woo! So for Avalanche, once you deploy your smart contract, you don't have to pay anything to kind of keep it up, to keep stuff in there. It's in there forever. That being said, the more that you deploy, the more gas it's going to cost. So if you want to deploy a gigabyte, into Avalanche, I promise you that is going to be too expensive for anybody. I don't know what the specific gas fees on Avalanche are right now, but I'm pretty certain if you try to deploy a gigabyte of data, you will need to be, Elon Musk pretty much to do that. Heard something about a link-based stablecoin in South America. Do you know anything about it? I don't. Sounds cool though. Also, I couldn't hear exactly the project working on that. To be honest, I game and want to rent my own NFTs. The idea came up, and it's not an OpenSea. Yeah, would love to see more projects doing kind of like an NFT rental service. That sounds awesome. Ability to activate/deactivate self-appointed oracles in dApp possible by individual users. Self-appointed oracles. I'm not sure what you mean by self-appointed oracles, but yeah, like if you're a DAO and you're a DAO kind of in control of governing a dApp, you can absolutely pick whichever oracles you want. And that's actually really good, right? You want to be able to have the flexibility in case an oracle is misbehaving, you can kick them off the network, right? So absolutely, I think that's what you're going for here. Good question. Are all of the Chainlink functions you mentioned, e.g. VRF, available on Avalanche testnet? Not yet, unfortunately. Price feeds is, and making any API calls are. VRF is VRF and keepers are in the process. So great question, really good question.
Hey, Patrick. Yeah, we got a couple on YouTube. So let's.
Oh, great! Yeah, hit me.
Let's go for those real quick. And I think you touched on this. Mr. Lee asks, what's the payload limit and how big is the data that can be stored on chain?
Yeah, this is a good question. So I'm not sure what it is specifically for Avalanche, but I do know, so there's like a max block size, right? And depending on how big that block size is, dictates how big your transaction can be and how much data you put on. I wouldn't worry about that for now because it's pretty big. But it is actually interesting. I guess just to go into a little bit, it is interesting because there are projects that have tried to deploy contracts that are like way too big or that have too much data, and there's a number of different ways you can actually get around that. One of them that's really good is called the Diamond standard, or the multifaceted proxy standard, which are pretty cool for deploying your smart contracts kind of in a really connected way if they're too big. But yeah, I wouldn't worry too much about that unless you're trying to dump gigabytes on the blockchain. But I'll just say this. So smart contract platforms are not great for storing a ton of data. So they're great for storing kind of the logic, right? And right now, there's not kind of a standard for a data layer though. So right now, people just kind of add whatever data, into the smart contract layer as well. But we have seen kind of like the rise of different projects like Filecoin or IPFS for maybe storing some data. For example, for NFTs, a lot of the data of the NFTs is actually stored in IPFS, and then the smart contract platform is just reading from IPFS. And that's how that interaction works. That way you don't have to store, maybe you have a massive image that's like a gigabyte image. You don't want to store that on chain because you'll break the bank. So good question. I kind of gave you the long answer, but hopefully that's what you're looking for.
Great. Awesome, Patrick. Thank you. We got another one from MGLA, and he asks, would I need to buy and spend Chainlink token if I want to integrate my project with Chainlink API? Yeah,
great question, actually. Yes. So this goes, actually, let me reshare screen here. That is a fantastic question. So when working with any Chainlink service or feature here, there is an exchange of link token, right? Link is the Oracle gas, or the link gas for making for connecting to the real world, right? If you want to connect to the real world, get some type of data, you pay the node operators Chainlink token to do so. So it's pretty interesting though. So for price feeds, you'll notice that, again, I'll go into this in a little bit. For price feeds, getting the latest price is actually just a view function. For those of you familiar with Solidity, you know that view functions can be called, without actually spending any gas, which means that you can just read the price, right? And that's because if we go to data.chain.link, right now, each one of these, this is an Avalanche. Chat, let's go to Avalanche. This means that all these price feeds that are up here are actually being sponsored by different protocols. So these are the sponsors that are paying the link token fees to keep these up. Now, obviously, the advantage here is that we get this decentralized, secure, reliable data at a fraction of the cost. So it'll be even cheaper than if you ran your own centralized Oracle, because kind of everyone's pitching in, right? And so right now it's set up in the way that just a lot of the large protocols that kind of have their whole livelihood depend on the price feeds are the ones pitching in. But otherwise you can just call a read function right from the application. Now, that's just for reading from these aggregated contracts. If you wanted to do what's called the direct request model, or maybe you want to get a random number, like a new random number, you do have to pay link to return a random number. Or maybe you want to, make an API call. In order to make the API call, you have to pay some link token. And the link token was actually specifically designed with this feature in mind, paying for some type of service to be done. Same thing with Keepers as well, but Keepers is a little bit different. Keepers is subscription based, so actually just you just fund a contract with a whole bunch of link, and that pays the oracles here. So really good question. Yes, there is a fee structure, and when we go into the demos, we'll show you that.
Great. There's a couple more, but why don't we just jump into the demo, Patrick, and then
Sure.
we'll get some of these questions at the end.
Yes, why don't we? Okay, so first we're going to start with price feeds here, because these are again, these are the main feature that's live. But again, I do want to point out, if there's something that you don't see here that you want to do that has something to do with real life, any API feature can do anything. So the any API feature is kind of this unlimited customization, unlimited flexibility feature. The issue, well, not the issue, but it does take, like I said, a little bit of extra legwork to make truly decentralized, and it's a lot easier just to literally go with the price feed. So we're going to go up to get the latest price. We're going to scroll down. This is the code here. There's a little deploy this with remix button that we're going to go ahead and click. It'll bring us to remix with all the code kind of already in here for us. So let me just walk through the code here real quick. And again, this is docs.chain.link. Let me pop this into the chat here. Okay, so here's our contract. Now, what it's doing, we have our Solidity version, obviously, and we're importing some Chainlink code. This is the Aggregator V3 interface. This is basically the interface for interacting with one of these price feeds here. We have contract price feed consumer, and when we deploy this, the constructor is the function that gets called whenever we deploy a contract. We're setting our Aggregator V3 interface to the address of whatever price feed, right? So in the documentation, if we go to contract addresses, we'll even scroll down to Avalanche data feeds. Each one of these data feeds, like I was saying before, has their own address, right? This is where the data is getting stored. The price information is getting stored. So if we wanted to read one of the test feeds, for example, we would just grab this address here, AvaX USD, and we would pop it right in here, right? So now we're saying, hey, the price feed is going to be this Aggregator V3 interface at this address, right? And then we'll update the comments, Fuji, and this is AvaX USD. And this is how it knows, okay, we're going to be working with that specific contract. Then we just call this latest round data function on the contract. And this returns a round ID, a price, start at, timestamp, and answered in round. For this demo, we just care about the price, so we're only going to return the price here. So we just go ahead and compile this. We're going to do injected Web3 here. We're going to make sure we're on the Avalanche Fuji C chain here. And if you're not familiar with setting up Fuji and MetaMask, I think if you do setup Fuji, MetaMask, Avalanche, there's probably, how to set up Avalanche with MetaMask. There you go. There's probably some docs as well. Yep, there's some docs in there to get Avalanche into your MetaMask. Then all we got to do is come down here. We'll switch to price consumer V3. We're going to deploy this contract, and if we've done it right, we should be able to return the price of AvaX USD on the testnet. Now, Remix gets a little confused. It thinks that the Fuji C chain is a main network. We know that that's not true. We'll just double check our MetaMasks when we actually deploy this. So confirm contraction. Are you sure you want to do this on a main net? It's not really a main net, but I just can see, okay, cool. This is the Avalanche Fuji C chain. Great, let's confirm. And what this has done is we've deployed this contract, and we can even grab this and we can look up C chain Fuji Explorer Avalanche. Yep, Explorer AvaX test. Oh, is this right? This display is Fuji testnet. Yep, okay. We can paste that address in here. Not found. Okay, well, maybe this is the outdated one. I actually forget. But we've deployed this contract to the Avalanche Fuji testnet. We can click this get latest price function, and we can see it does indeed return the latest price. Now, again, why is this number so wonky? Why does it not look like the real price? Well, we remember decimals don't work in Solidity, so we know this is multiplied by a factor of 10. So it's actually 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 decimal places, so we know that this is actually $60. And that's it, right? That's all you really need. And now you can build the next $2 billion protocol. That's how you use price feeds. Oh, is that the right one? Somebody just sent me, oh, is this the right one? Test that work? Paste that in. Aha, there you go. Okay, that's the right one. Yes, and that's the contract that we just deployed here. Boom. So that's it. It's that easy. We'll do a hard hat and or brownie and or truffle demo in a second too. But are there any questions on that? Or is that incredibly straightforward? Or is that confusing?
Nice. Don't see any on Zoom. And then there's a few on YouTube, but why don't we wait till the end for that?
Okay. Let me do a quick poll. Can I do polls here? Okay, just post in the chat. So we're gonna do a hard hat or brownie or truffle demo as well. Which one do you want to see? Brownie, hard hat, truffle. Put in the Zoom chat here. Okay, 1 for hard hat. Anybody else? Any other takers? Truffle, hard hat. Oh, 2 for hard hat. 1 for brownie. Oh, Jason. After somebody put in the Q&A, hard hat. Okay. It looks like hard hat is taking the cake here. Hi hat. Okay, somebody wants hi hat. I'm not sure. I'm not familiar with hi hat. That sounds a little different than hard hat.
I think you need to play the drums or something.
All right. Okay, so we're gonna do hard hat here. Let me open up hard hat code. Just get my Visual Studio Code up here. Then we'll do a little share screen with VS Code. Bada boom. Can we see that? I think we can. Okay, cool. Oh, actually, just kidding. I'm going to stop sharing screen and I'm going to reshare screen. So this is the Hard Hat Starter Kit. It's under Smart Contract Kit / Hard Hat Starter Kit. I'll pop this into the chat here. It's a ton of boilerplate for getting started with Chainlink. And deploying these, these empowered smart contracts, and it works with any EVM compatible chain. Obviously with Avalanche in particular. So this is what we've Git cloned. If you're unfamiliar with Git cloning, take a look at the README in there, and I believe there's a link to actually to download Git clone, download Node.js, download Hard Hat. So there's a whole bunch of kind of prerequisites here. If you go to the README, and again, this README is on the GitHub itself. It's got an adorable, cute logo. You want to walk through the requirements. If something doesn't make sense, make an issue on the repo saying, "Hey, I couldn't do it because X," and that's perfect. So, a couple things that we need. We need to Git clone it. You need Git. You can see Git with Git -- version. You need Node.js, Node -- version, and Yarn -- version. So those are the 3 things you need to have installed before doing this. And again, instructions on how to do that are in that README, so you can go ahead and do it. But once you've Git cloned it, you can just run yarn. This will install all the packages. I have already done this, and we're ready to go. There's a whole bunch of different things we can do here. One of the most powerful is running our tests. But let me just walk you through this repository and tell you kind of what's going on here if you're unfamiliar with Hard Hat. So we have our contracts folder, which is going to have all of our contracts. As you can see in here, some familiar faces. This is going to be exactly nearly exactly the same code that's in the documentation here, just a little bit more parameterized for making API calls, for getting a random number, or excuse me, for getting a price feed and for getting a random number here. We have tests in here. This is for running tests. We use an idea or a methodology called mocking, where we mock contracts and we mock interactions so we can run our tests much quicker when working on a local chain, so we don't always have to wait for our transactions to go through on a real network. We have our deploy tab, which is incredibly powerful, and it will run these scripts whenever we want to deploy some contracts or work with some contracts to send them. We have deployments, which keeps track of all the deployments. We have the node modules, which is obviously our NPM packages. We have some tasks, which are some helpful, nifty little scripts that we can run in the event that we want to do some task that we need to regularly do. And then, of course, tests for doing our tests. We have integration tests that will run on like a real test net, right? If we want to test working with a test net or a mainnet. And then obviously we have our unit tests that are for running locally, and kind of, they're just much quicker for testing all of our functions and everything. We do have this .env.example, which I'll talk about in a second, but the main, the important pieces for really getting started here are going to be this hardhat.config and this helper hardhat config.js. So this hardhat.config in this module.exports, it's got this networks flag, and these are all the networks we can work with when working with, our smart contracts. So as you can see right now, Avalanche isn't in here. So to add a new network, we would just do Avalanche, some brackets, and we need a URL, a way to connect to Avalanche, and a way and some type of wallet, right? So you can see for Ganache, it's using a mnemonic, and for Mumbai, it looks like it's using a private key. So you can literally just copy paste. I actually usually prefer working with private keys than mnemonics, but I would just do something like this. And for the URL, this is going to be, your RPC URL that kind of that you use to set your MetaMask up with. So it's going to be like Ava XC chain, chain rpc.com or something like that. I forget what it is. But you'd set up like that. A lot of these are using an environment variable like ringp rpc URL. If we scroll up, process.env ringp rpc URL, and you can actually just put those in a .env folder. So if you want, you can make a .env. You do like private key equals whatever your private key is, and then Ava X RPC URL equals whatever that is, right? And those will be your environment variables for working with your network. And here's kind of an example of what this .env will look like. I'm gonna go ahead and delete that for now though. But once you have your network up, and again, I'm just gonna delete this for now though. But that's essentially all you'd have to do. Once you have your network in your hardhat config, you would just add in our helper config any addresses that we need, right? Because each network is going to have different addresses for, the ETHUSD price feed, for the link token, for a key hash, for a V coordinator, for a fee, etc. And so you would just copy paste this as well. What's the chain ID for Avalanche? I forget. Is it like 18? No, I'm not even gonna try. So you would just do the same thing. You would change this for the network parameters for Avalanche, and then you'd be good to go. So once you were to add that in, you could just run hardhat deploy -- network, whatever you named it. For example, if I wanted to deploy this to Coven, I could go ahead and deploy this to Coven right now because I do have a Coven RPC URL, and it's going to go through the whole process of deploying all those contracts. It's going to walk through this deploy script, and it's going to do everything. I'm actually just going to cancel it for now because I don't actually want to walk through. But if you want to deploy to an actual network, like the Avalanche C chain, that is how you do it. Now, with all that being said, usually deploying to a testnet is going to be really slow. It's going to kind of suck if that's how you're going to do your development process, because you don't want to have to wait 10 years for your transactions to go through, which I know it's a few seconds on Avalanche, but we want to be as quick as possible. So typically, what we do when we run our tests is we run them on what's called the hardhat runtime environment. So if we do, oops, sorry, I have a shorthand installed, but the longer command is npx, hardhat deploy -- network, blah, blah, sorry. Whenever I use HH, that's the same as npx hardhat. It's just the shorthand that I've installed. But yeah, if I want to run my tests on a local chain, we have our tests set up here. You can go ahead and check them out and see what we're doing to run these tests. But this will run on a local chain with a bunch of these fake contracts. And to run them, we can just do npx hardhat test, and this will run through all of our tests. And as you can see, that's way faster than actually deploying to a testnet. That just deployed all of those contracts, and it called a ton of functions in like a fraction of a second. So this is why we pretty much always want to be testing locally. We can even mock like interacting locally as well as doing our tests. So if I run npx hardhat node, what this will do is it'll spin up a fake blockchain, a fake hardhat runtime environment right in front of our eyes, basically. And it walked through our deploy script. So it deployed all those contracts. And as you can see, it talked to us a little bit here. So first it said, hey, we're going to be deploying our mocks up here. And then it gave us a big, just like kind of heads up, saying like, hey, if you want to, work with the console, you can absolutely do that. But it also gave us some scripts. So for example, for price feeds, if we want to read one of these price feeds, we can run this command, npx hardhat read price feed, which is one of our tasks that we've created in here, read price feeds. Contract right here, network localhost. I can copy this, paste it in, and this is going to read a price feed from our fake blockchain that we just spun up, and that's the address right here. And this is how we can build these applications much quicker, much faster, and work with these blockchains and locally test, our Avalanche or our insane, new DeFi protocol using these price feeds, using these APIs, using Chainlink and combining Chainlink and Avalanche together to make something really cool. So with that being said, that pretty much will give you all the tools to do whatever you want to do here. So we have about 12 minutes left. So I'm happy to take any questions and talk about really anything that you guys or that everyone here is curious about.
Great. Well, I think everyone really enjoyed that one. Okay, so we got a couple from YouTube. First one is states, does anyone know of a no-code logic builder that'll convert to smart contracts?
That would be cool. In my mind, that's kind of Solidity, because as your no-code logic builder will just become more and more code, right? Because if you're like, oh, I got an if-then, well, you can do that in code too. I think there are a couple solutions out there like that. I know there's some like no code, like DeFi composability things out there. But honestly, if you're looking for like a no code smart contract builder, you might as well just, become a smart contract engineer. Yeah,
plug it, Patrick. I think I know what you're going to plug.
What am I going to plug? What am I going to plug?
Bootcamp, right?
I'm not actually going to plug the bootcamp, but
okay.
You should check out the bootcamp as well. Actually, I'll plug the bootcamp too. So I just posted a link in the chat. It's a 16-hour free code camp course that goes through everything smart contracts related. So it is Brownie, but if you're brand new to Solidity, the first 4 or 5 hours or something like that is like all remix. So it's just core Solidity stuff, and then it goes into Brownie, which then kind of takes all this testing and Solidity, combines them together. I tentatively have a hard hat edition in play, but yes, as well, Chainlink Bootcamp. This is a really cool bootcamp that we did maybe 2 months ago, a couple months ago. Same thing, took everyone through kind of everything. There is a hard hat and Brownie edition. There are videos as well if you want to check out the videos. So definitely check out the bootcamp. That was a ton of fun, where we worked with just a ton of brand new engineers and from scratch took them to deploying smart contracts, on the blockchain. It was an absolute blast. Jason, great question here. What are the advantages of Brownie hard hat truffle? This is a great question. So the main difference between Brownie and the other two is that Brownie is Python based. That's pretty much it. So what these smart contract development frameworks do is they allow us to test, deploy, and kind of iterate on our smart contracts much easier, right? In a production environment. They allow us to, all of your smart contract stuff is going to be written in Solidity, but then the tooling around it, like how do you deploy, where do you deploy, it's going to be built in a traditional language, like Python or JavaScript. So the main difference of Brownie here is that Brownie is Pythonic. Brownie is built in Python. So if you like Python, I personally really like Python. you can work with Brownie. Hardhat and Truffle, let me talk about those for a second. Those are both JavaScript-based smart contract development frameworks. A lot of, if you were to look at the top 20 DeFi protocols, I think probably 14 of them are using Hardhat. Hardhat is, and the rest are using Brownie. So that's kind of the breakdown there. I want to say like 80% of DeFi projects use Hardhat, maybe 20% use Brownie. There are some that use Truffle as well. And Truffle is, but yeah, I'm not sure why not as many protocols are using Truffle anymore. Truffle was actually one of the OGs, and they've done a ton of work to kind of really set the foundation of kind of all these frameworks. And Truffle is greatly integrated with Ganache, if you're familiar with Ganache. But yeah, I mean, it's all dependent on what you want to do and what you're familiar with, right? If you like Python, use Brownie. If you like JavaScript, use Hardhat or Truffle. And that's kind of it. And yeah, when I am doing JavaScript, I usually do Hardhat as well. But I do have a ton of demos still in Truffle out there as well.
Sweet, that was a great question.
Yeah.
Okay, I'm seeing a lot of comments on YouTube. When VRF on Avalanche. So we can't really speculate on that a whole lot, but maybe Patrick, you could elaborate on some of the just most exciting projects that are using VRF currently that you're stoked about, and maybe some use cases that aren't quite there yet, but you're really excited about.
Yeah, to answer your questions, YouTubers, sooner than you think, but not as fast as you expect. That's just my default. Like, I'm not answering your question or answer. Yeah, so VRF is insane. Like, that is like one of those big brain, like, oh my goodness, this exists. You can cryptographically prove a random number. Absolutely wild. On Ethereum mainnet, probably one of the most interesting ones, I think, in the DeFi space is definitely Pool Together. So Pool Together, I think, is really cool because at first you think, oh, it's kind of it's a lottery. That's cool, but the expected return with Pool Together is actually higher, which was absolutely wild to me, than people individually, investing, which I thought was absolutely insane. The caveat, of course, is that you have to be the lucky winner, right? Or you have to be the lucky winner often enough. So they're using Chainlink VRF to randomly, give out the winners to their protocol, which is kind of like this really cool yield aggregator, or maybe that's not quite the right term. But yeah, they do DeFi stuff and they gain interest, and they give out the return to one person every week, which is really cool. So, and that person is chosen randomly with Chainlink VRF. The NFT market is absolutely insane with Chainlink VRF, and I absolutely love how serious they're kind of taking the scarcity of their protocols. Something we've seen in the past is protocols going, okay, cool, I'm just going to use block hash or whatever, and then they get hacked because that's not a true way to get random numbers, and that makes my heart sink, and that makes me really sad. But additionally, doing it in that way means that kind of the owners or the owners of the contract can kind of manipulate how many tokens are minted or how many things are minted, ruining kind of the scarcity of your NFT, right? In the traditional, card trading world, or excuse me, in like the meat space, if you will, if you're a company, you're often highly incentivized to just print as many cards, as many rare cards as you can to make a whole bunch of money off of them. But if you do that, you dilute the cards. But if you're super sketchy, you just don't say how many of those rare cards you minted. So you kind of keep the price nice and high. Chainlink VRF gets rid of all that and makes it an incredibly fair consumer system where you'll always know exactly how rare something is, right? There will be no shady, weird misgivings on the back end. And we've seen a ton of projects like Bored Apes is using it, I think, for their mutants and for their random drops. I don't actually remember exactly where in the code it is, so don't take that at face value. I know they're doing something, but like something like Avalanche is using NFTs, Pokemon's, Ether cards, Axie Infinity for random, drops, for stats, for battling, for random characteristics on your NFTs. And that's something that's just absolutely exploded recently. And it's a ton of fun. And we've got a ton of examples on how to do that as well, if you're interested in learning. So we've made a ton of videos, a ton of blogs on doing that. And that's just been a ton of fun to see the NFT space really understand randomness. Great question. Great question.
Fantastic. Well, hey, we are just up on time here. So I think that's the number of questions. Yep, we'll go ahead and close out. So Patrick, want to thank you so much for being here. Thank you for imparting your knowledge on both, the Avalanche community, but also the Chainlink community. I know there's a lot of synergies there, and we both appreciate, both communities appreciate you being here and kind of imparting your knowledge upon us. So with that being said, why don't you maybe plug places where people can maybe reach out to you personally, maybe give you a high five virtually, that is, and anything of that sort.
Yeah, sure. And thanks so much for having me. Again, I know there are a ton of synergies between Avalanche and Chainlink, so always a blast to be working with everybody here. But yeah, if you want to reach out to me, I'm on Twitter, Patrick Alpha C. I'm on YouTube as well. I'll plug the YouTube. Sometimes I make serious videos. Oh, sorry. Sometimes I make serious videos on my YouTube. Sometimes I don't. Also, be sure to check out the Chainlink documentation and the Chainlink YouTube. Chainlink Hackathon is going to be absolutely wild. Jason, I see you in the chat. That is absolutely the right choice, my friend. It's going to be like one of the biggest events in the space for the year. So really excited about that.
Great. And for everyone in the Avalanche community, Avalanche Rush is on full display at this moment. So DeFi is popping off on Avalanche. Bridge your tokens over and let's have some fun. But again, Patrick, thanks for joining us. We have a lot more in the pipeline actually between the Chainlink and Avalanche communities. So stay tuned. Probably the best place for that is on Twitter. So that being said, thank you everybody, and we'll talk to you soon.
Bye all.
Bye-bye.
YouTube, yeah.
There we go. Tell us about your frog in the background.
Oh yeah. It's just my Twitter avatar, and I neoned it and put it up on the wall to kind of have something cool. That's really it. I had one of the Link Marines in the community. His Twitter tag is literally the Link Marines. He made it for me, and I freaking love it. So it's like my favorite thing that's come out of this space.
Sweet.
Art wise, that is. Tech wise, there's a million things.
Have you made it into an NFT yet?
I've done so much NFT work. I don't know if this is actually an NFT. I know Patrick Alpha C .eth is an NFT. I should turn this into an NFT and drop it into maybe I'll drop its original dropping into Avalanche. Maybe that'll be its claim to fame here.